Now we're going to say the fourth question. Okay, fourth example. The question is secant a minus tan a divided by cosecant a plus cot a, okay, which is equal to cosecant a minus cot a divided by secant a plus tan a. This was the question. This question is somehow interesting. We are not going to directly use any formula like previous sums we have used. We directly don't going to use any secant formula or tan formula or cosecant formula or cot formula. You can see in the question itself the LHS and RHS. You can observe it properly that both are having the little changes in their signs alone, but the values are same. Can you see it, right? Here it is secant tan, cosecant cot. So you can seeing this itself, you can see that we directly don't going to use any formula for secant or tan, going to substitute it and all. Okay, there will be definitely an easy trick for these type of sums. When you see these type of sums over LHS and RHS having little much changes in their signs alone, the values are similar, means there is definitely going to be a trick formula over there. Okay, we're going to use that only over here. Okay, we already know the formula of secant square theta minus tan square theta, which is equal to 1, and also cosecant square theta minus cot square theta, which is also equal to 1. The same sin square theta plus cos square theta is also equal to 1. These are the one answer coming formulas. Okay, now we are just taking these two alone because the question is similar to this, right? Secant tan, cosecant cot. So that's why we are just taking these two formulas alone. Okay, you can also write this as secant square theta minus tan square theta, which is equal to cosecant square theta minus cot square theta, right? Because both their results are 1, so we can also write both their values will be equal, right? So I am just equally writing secant square theta minus tan square theta is equal to cosecant square theta minus cot square theta. Okay, now I'm not substituting any secant formula or tan formula. I am just substituting the basic algebraic formula, which is a square minus b square. See, both the sides are similar to this formula only, right? A square minus b square. So a square minus b square formula is equal to a plus b into a minus b. So I'm just gonna use this formula only. Secant square theta minus tan square theta is equal to secant square theta minus tan square theta plus secant square theta plus tan square theta, right? So here in the question you also see instead of theta there is a, so we can write the values in a instead of theta. Okay, so instead I am writing over a over here instead of theta. Okay, I am just converting it. Okay, and now further approaching secant square a minus tan square a, secant a plus tan a, secant a minus tan a, okay, which is equal to, now this side, cosecant a plus cot a into cosecant a minus cot a, like a plus b, a minus b, a plus b, a minus b. Okay, now seeing the RHS and LHS, see how the question is and what we need to prove. See, there is secant a minus tan a in the LHS, so keep secant a minus tan a here itself. Okay, in this LHS itself. Okay, just move secant a plus tan a from LHS to RHS, because in the question then for LHS numerator is minus, so that's why we keeping the minus alone over here. and moving the plus to LHS to RHS. On the similar, here on the top, okay, on RHS on the top there is cosecant A minus cot A, so keep cosecant A minus cot A here itself and moving this plus from RHS to LHS. Okay, both the values are in multiplication, so when you moving from LHS to RHS, RHS to LHS, it will become divide. So the same methodology, secant A minus tan A, in the LHS alone I am keeping in the numerator, okay, equal to, here by the same cosecant A minus cot A alone I am keeping in the numerator. Okay, when we moving here, first we go with the LHS, here we moving secant A plus tan A from LHS to RHS, it will become divide, so secant A plus tan A comes to the denominator. Here by the same cosecant A plus cot A from RHS to LHS, it will become divide, so cosecant A plus cot A comes to the denominator. And now check, we have proved the values on both the side. Yes, right? If we solve it like which we have solved the before sums, taking LHS, then putting the formulas, also you will get the answer, like it will take too much steps. By seeing this, you can see this, there is only just 3 or 4 steps. Just using these formulas, both are having the same values, so keeping it in the equating it, and both the values equating it, both are similar to a square minus b square, just substituting according to the formula a plus b into a minus b. Okay, now according to the question, I am just keeping the values which need to be on the numerator, which needs to be on the denominator, which needs to be on the LHS, which needs to be on the RHS, and that I'm just moving the except things to the other sides, I will get the answer. So hence proved. Okay, this is one of the easiest sum, the trigonometry. Okay, just go through it.